All right, we have another. Beats code. Medium. Companies seem to love this problem. Fine companies seem to love this problem. And it's the kth largest element in an array. So find the kth largest element in an unsorted array. We need to find the kth largest element in the sorted order, not the kth distinct element, okay? Whatever that means. So in this case, k is 6, we have this number. What's the 6th largest number in this array as it is right now? That is 4, because you go from 9, 8, 7, 6, 5. So I've counted 5 numbers, and number 5, the 6th number is 4. That's why we have 4 here. This is the 3rd largest number in this array. A minimum heap that we set to a size of k, whatever k is. In this case, k is 3, so we're looking for the 3rd largest number in this array. So first seed it, right, with the first three numbers in the minimum heap, so the smallest number is on top. And every time we now go look through the rest of the array, and every time we see a number bigger than what's on the root of our minimum heap, we kick it out, pop it, and push that number in there. So in this case, 2 is going to be in there, 1 is going to get kicked out. Here, 11 is bigger than 2, so 2 is going to get kicked out again, 11 is going to be there. The heap property is maintained, so for those 3 numbers, when 11 is here, 5 is the smallest, so that becomes the root of the heap. Same, 9 is going to kick 5 out, 7 is not going to kick 9 out, 30 is going to kick 9 out. Now 11 is the smallest thing among these 3, and 40 is definitely going to kick 11 out. Then we have 12. We've gone through the whole heap, so we can just return the root, and we have our value. Now what does this look like in code? What does this look like in code? So we pass in the numbers, unsorted list of numbers, the k, the position we're looking for. We initialize our minimum heap over here. Now I'm not going to go into the details, implementation details of a minimum heap or priority queue, because a lot of languages come with included in a standard library, and there are packages you can install that would give you that feature set. But you can feel free to look.
In this video, we're going to be tackling the LeetCode question, kth largest element in an array. This is a very common real-world problem. This is also up there with one of the most common interview questions. But first, just like any algorithm, we need to first identify which pattern we need to use. And if we look at the title and if we look at the description, we see 2 very important clues. First things first, in the title, we see something along the lines of top K. The top K elements pattern is seen all throughout LeetCode. Top K should be the very first clue on how to solve this. The second is that in the description, we say we should use. That's based on a heap. Both of these should be sufficient enough to pass a coding interview. But I must say, Quick Select is the superior algorithm because its time complexity is linear compared to the nlogn that the heap has. Also, quick select is very handy to know because number one, most sort methods that you see in, let's say, C# or Java are going to be built upon quick sort. Quick select is a derivative of quick sort. Also, this is one of the few cases that you will see in computer science where the time complexity actually improves with recursion. And it's very important to learn that just for that sake. You need to actually do. To put it simply, we're going to be given two things. We're going to be given a single number represented by k. We're also going to be given an array of numbers, multiple numbers. But what exactly does k mean? We usually see n, but what's with the k? Well, k, whenever you see the word k, think Olympics. Like, what place did you come in? What position did you come in? If you came in first, you get the gold. If you came in second, I think you get the silver, third, bronze, and you get the picture. What position did you come in? And in our case, we're coming in second place, so to speak. So what we're going to do is we're going to find the second largest element in the array, which in our case is going to be, you guessed it, 5. Because 5 is the second largest element in the array. Okay, you get the picture. How exactly do we solve this? We're going to solve this with quick select, but what's the first step? The first thing that we need to do is we need to partition the array. And that sounds very scary, but let me explain. A partition is basically the Bud Light of sorting. With a fully fledged beer, a fully fledged sort, there are many situations where you definitely want to sort. But number one, we can't sort. And number two, if we do a fully fledged sort, our time complexity is going to be really high. So what we do is we partition it. A partition works like this. First things first, we select a random number. Literally does not matter which number that you pick. You purposely pick a random number out of all of the numbers in the array. The second thing that you do is you divide the elements into less, equal, and greater. So what we will do is we will create 3 new lists. We will create 3 new dynamic arrays. Then what we'll do is we'll iterate through each number. And if the number is less than the pivot index, you guessed it, we're going to place it within our less than array. Then we'll move to the second element. We'll do the exact same thing. It's less than our pivot index, so we're going to place it in the less than array. And 1 is, you guessed it, less than 5, so it's going to go in the less than array. Once we get to the actual pivot index, we'll go ahead, we'll place it into the equal array of our pivot index. We'll do 6. 6 is greater than, and 4 is less than. And congratulations, you just figured out what a partition is. It's pretty much like we're sorting it, but not sequentially. We're sorting it to a certain extent. It's the pivot index. You guessed it, we're going to choose the number that you pick. You purposely pick a random number out of all of the numbers in the array. The second thing that you do is you divide the elements into less, equal, and greater. So what we will do is we will create 3 new lists. We will create 3 new dynamic arrays. Then what we'll do is we'll iterate through each number. And if the number is less than the pivot index, you guessed it, we're going to place it within our less than array. Then we'll move to the second element. We'll do the exact same thing. It's less than our pivot index, so we're going to place it in the less than array. And 1 is, you guessed it, less than 5, so it's going to go in the less than array. Once we get to the actual pivot index, we'll go ahead, we'll place it into the equal array of our pivot index. We'll do 6. 6 is sorting it, but not sequentially. We're sorting it the Bud Light metaphor. So congratulations, you just got through the hardest part. Learning how to partition is the hardest part of this algorithm. Everything's smooth sailing downhill from here. All that we need to do is just partition again. Need to partition one of these arrays that we created in the less than, equal, or greater, but which we don't even have enough elements to determine the position of k. Our pivot index, which is the equal, isn't equal to the number that we're searching for. So the only logical solution is that our number could be in the less than array. And we're just going to do the same exact thing. We're just going to partition the less than array via recursion and to determine a random, as we're going thing with 2 to keep partitioning through the we just partitioned through. So the computer's going to set a random to is greater than the pivot index. So we're going to play equal again. Very chooses 3. 3 is our pivot index. It's not less than. Element is going to trigger our base case, and that pretty much means that we have found our kth largest element. So let's go ahead, let's hop over into IntelliJ, and let's code a brand new Java class. And I'm going to call this solution. Okay, and of our pivot index, we'll place the second thing that equal and list. Equal 6 is each part equal and then bit of greater element to happen is actually part that LeetCode actually wants from us. The find kth largest. It's going to take in an integer array of nums, and it's going to also take in an integer called k. The next thing that we're going to do is we're going to create a first we're going to so I'm just going to use a list. Then what we're going to do is we're actually going to create our quick select. And what I'm going to do is just create a method called quick select, and we're going to pass in our list, and we're also going to pass in our k. So now we need to build out our second method, which is going to be the quick select algorithm. We're going to call this quick select. It's going to take in a list of integers. We'll call this list of integers nums, and it's also going to take in an integer called k. So we're going to be using recursion. We're going to have a quick base case check. So if the size is equal to 1, that means we don't want to continue partitioning. So we're going to go ahead and return the first element in the num. Now what we're going to do is we're going to create our pivot index. Now this isn't the actual number, this is just the index. What we're going to do is we're going to use random. We're going to check the size, and it's going to generate a random number based off the size. Then what we're going to do is we're going to actually grab that index out of the nums, and that is our pivot. So we've gotten our pivot chosen. Now what we need to do is we need to sort those numbers based on the pivot. This is going to be kind of repetitive, so what we can do is we can copy and paste this, but we're going to say less, we're going to say equal, and then we're going to say greater. And these are all of the arrays that we're going to use to sort and partition the elements in the array. Now what we're going to do is we're going to create the logic, the iteration, that's going to place the element within the array into the appropriate less, equal, or greater. This is super easy. All that we're going to do, we don't even need to use a fully fledged for loop. We can just use a for loop with a colon in it. Then what we're going to do, and then so what we pass also minus the equals are also going to be given. So there are many situations where you definitely want arrays. Then what we'll do is we'll iterate through each number, and if with x, or hence the hardest part, smooth sailing downhill from here. All that we need to do is just partition again. We need to partition one of these arrays that we created in the less than, equal, or greater array. We don't even have enough elements to determine less than or equal. The pivot index, we're going to keep partitioning through the greater array. We can go ahead and equal to, so we're going to place it in the equal. 4 is greater. We still haven't found
In this video, we're going to take a look at a legal problem called minimum size double-array sum. So we'll give it your array, use a window and have 4 items because we met the condition, which is going to return 0. The
No. என்னது என்ன சொன்ன
So hello everyone and welcome